recall what is linear equation. So for that, suppose ax plus by is equals to c. If I am writing this one, that means this is equation of a straight line. Okay, you already know this. Or if I write ax plus by plus cz is equals to d, then this is also, it is well known to you that this is equation of a plane. Okay, now see, both of this equation, if you just observe these two equation carefully, there is no square, there is no multiplied form of xy or yz like that. Okay, so these equations are known as linear equation. Okay, whereas this first equation, it is straight line, this means it is in 2D. This equation, it is equation of a plane, that means it is in 3D. So if we consider, suppose a1x plus b1y plus c1z is equals to, suppose d1, a2x plus b2y plus c2z is equals to d2, and suppose a3x plus b3y plus c3z is equals to d3. Then see, this is a system of linear equations. Okay, and each of these equations, they represent one particular plane. Okay, now there may be cases like this, whether these three planes intersect through a particular point or not. Okay, that means what about the intersection of these three planes, whether they intersect or not. That means, suppose if we consider in 2D case, well, this is one line, this is another line, they intersect through this point. Okay, through this point. Similarly, if we consider 3D, that means suppose this is one plane, you need to visualize this. Suppose this is another plane, this is another plane, and suppose the third plane also, suppose here you have the third plane. Okay, so whether they intersect through a particular line or through a particular point, or whether they are like this, that means parallel planes. Okay, or like this. Okay, so based on that, you have three different cases. That means whether solution exists or not, that means solution, unique solution, or infinitely many solution, If solution exists, then you have these two cases, and another is no solution. Okay, so these first two cases, this is called the consistency. That means the system is consistent. Here the system is said to be inconsistent. Okay, so we have different conditions based on which we can draw the conclusion that whether a system is consistent or not. Okay, so for the time being, you should know that a system is said to be consistent if either unique solution or infinitely many solutions are there. If no solution, then it is inconsistent. The system is inconsistent. Okay, now see, when we have a system like this, we are considering this 3D case. The same scenario you will have for 2D as well. Okay, just the corollary of that you can take in 2D. Now for 3D case, suppose we are having this system. So corresponding to this system, you have a matrix representation. That means the matrix representation of the above system, it is as follows. That is, ax is equals to b. You can write like this, where a, it is a1 b1 c1, a2 b2 c2, and a3 b3 c3. This is also called what? Coefficient matrix. Okay, coefficient matrix. You are just taking the coefficient and just form a matrix representation. And b, this is, see, d1 d2 d3, and this x, it is x, y and z. Now see, here one thing you should observe, if b, we are taking b as non-null vector. Okay, if b is 0, so in that case, if b is 0, so immediately the system is homogeneous. Okay, system is homogeneous. So in that case, 0 0 0 will always be the solution for the given system if it is homogeneous. Okay, now see, 0 0 0 means you have the origin. That means all the plane whatever you are considering, they are passing through origin. This is the point if we have the homogeneous system. Now see, for the time being we are taking b not equals to 0, that means non-homogeneous system we are interested on. Now when you have this matrix representation, immediately one important term, that is augmented matrix. Corresponding to that, you have the augmented matrix which is represented like this, A augmented B. That means the first part of this matrix will be from A, that means A1 B1 C1, here A2 B2 C2 and A3 B3 C3, and here you have D1 D2 D3. Okay, this is the augmented matrix form. Now see, we have the consistent case, that means the system is consistent. You should note this one, the system is consistent. That means under that you have the unique solution. The first part, unique solution. For that, rank of A, it is equal with rank of A augmented B, it is equal with number of variables. That means number of variables. Second one is infinitely many solution. That means rank of A, it is same as rank of A augmented B, but they are not equal with number of variables. So in that case, it is basically less than number of variable. And another is inconsistent. So what you have, see, no solution. So in that case, the result is rank of A, it is not equal with rank of A augmented B. Now this is the important result, you should be knowing it. Now you can make this one as note. When you have, see, rank means immediately you should take help of row reduced echelon form. Okay, row reduced echelon form, that means RREF, row reduced echelon form. Okay, so this is one of the important technique by which we can find rank of a given matrix. Okay, so row reduced echelon form means immediately you should be knowing this elementary row operations. So what exactly those elementary row operations are, you can go through any standard textbook, you will find it. But anyway, through the question I will illustrate the facts, how to get this row reduced echelon form, and finally decide what is the rank. And in between, in the intermediate steps, we will find these elementary row operations as well. So first let me take one question. Through the question we will try to understand these concepts. Okay, and this particular topic, that is row reduced echelon form, this is very vital, and try to understand this thing from examples. Okay, now we are going to example. So first write down this question. Check the consistency consistency for the following system. So take the first question. System is x plus y plus z is equals to 6, 2x plus 2y plus 2z is equals to 12, and x plus y plus z is equals to 7. Okay, so this is our system. This one is our system. So check the consistency, means here first the matrix, the corresponding matrix representation, first you need to write Ax is equals to b, where A is equal with this, write down all the coefficients, 1 1 1, 2 2 2, 1 1 1, and here you have b is what, 6 12 7, and x is what, x y z. Okay, so next work will be what, see, we're interested on the rank of A augmented B. Okay, so next we'll set up A augmented B matrix. So see, what is A augmented B? A augmented B, if you write this, it will be 1 1 1 6, here 2 2 2 12, here 1 1 1 7. Okay, this is the next work, that means writing the augmented matrix. Now our target will be to reduce this one into its row reduced echelon form. So for that, see, this is the first pivot entry and you have to make it 1. If it is already there, that is fine, your job, it is easy. So already this first pivot entry, it is 1. Now this element and this element, you need to make them 0. So how you can make them 0? See, second row, this is permissible, second row minus 2 times first row, so that this entry it becomes 0. Okay, so immediately what you have, see, first row as it is 1 1 1 6, here you get 0, see here 0 0, that means component wise you are just subtracting. See, when you are writing r2 minus 2r1 means r2 is 2 2 2 12, and first row all the elements get multiplied with 2, and here you have 2 2 2, here 6 means 12, so subtract it, so you are getting 0, all 0. Okay, next is what, this entry you need to make 0. Okay, so r3 dash will be r3 minus just the simply r1. So if you are doing this, so what you have, see, 1 1 1 7, here first row what you have, 1 1 1 6, so to the subtraction you have 0 0 0 1, so 0 0 0 1. Okay, fine. So this is the row reduced form you are getting. Okay, so here you have this first pivot entry 1, below all the elements, this one 0 0 0. Okay, next work should be here, this position you need to make it 1 if it is suppose if it is the case for non-zero, but already you got here everything 0, so nothing can be done here. So this is the row reduced form. Okay, so if you just consider this row reduced form up to this part, from this part, this is coming from A. Okay, so rank of A is what, 1. See how many independent rows you are getting from this part, you are getting only 1. Okay, so rank of A is 1, but as a whole if you consider this entire matrix, see, this is one row, this is another row, and both are a non-zero row as well as they are independent. Okay, so you have rank of A augmented B as 2. Okay, number of independent rows, so you are getting 2. That means from here rank of A, it is not equal with rank of A augmented B, so the system has no solution. That means the system is inconsistent. Okay, the system is inconsistent. This will be the final conclusion. Now just go back to the equation and see In fact, if you just consider these three planes, they are nothing but parallel plane. Okay, they are parallel plane. Just observe these three equation carefully. They are parallel plane, in fact. Okay, so there is no solution. The system is inconsistent. Now we'll go to another question. So under that same question, the second system you can take like this. Check 2x plus 3y minus z is equals to 5. Then 4x minus y plus 2z is equals to 6, and x plus 2y plus 3z is equals to 7. Okay, so this is your system 2. Okay, this system 2 will check whether unique or infinitely many solution or no solution. We'll check it. Okay, so for that, see, first work is to write the augmented matrix. That means you can write it directly, or you can first write A then B. So I'm writing it directly. A augmented B, it is 2 3 minus 1 5, 4 minus 1 2 6, 1 2 3 7. Okay, so this is the augmented matrix. Now you need to convert this one into its reduced form. So first work will be to make this position as 1. So for that, the easiest possible thing you can do is, see, R1 interchange with R3. This is permissible. Okay, interchange of rows are permissible. So what you have, 1 2 3 7, here 4 minus 1 2 6, here 2 3 minus 1 5. When you are doing this process, you should be very careful. Okay, now see, next work is what you are getting here 1, that is fine. Now you have to make this entry 0, and this entry also 0. This is called first pivot entry. When you have this pivot entry as 1, so immediately this position and this position you need to make 0. So what we will do here, see, the next step, see, you can do R2 dash tends to R2 minus 4R1. If you are doing this, what you will get, see, R2 means 4 minus 1 2 and 6. Okay, and 4 times R1 means 4 8 12 and 4 means 28. Do the subtraction, 0. What you have, see here, R2 means 8 minus of minus 1, that means 9, 12 minus 2, that is 10, here 28 minus 6, that is 22. So 1 2 3 7 0 9 10 22. Okay, now next what you can do, see, R3 dash tends to R3 minus 2R1. So R3 is what, R3 is 2 3 minus 1 5, 2 3 minus 1 5. So here 2 4 6 14. So what you are getting, to minus 0 1, here 6 minus of minus 1, it is 7, 14 minus 5, it is 9. So 0 1 7 9, this thing you are getting in the next step. Okay, so you can keep this one as it is. Okay, next is what, you need to make this position 1. So for that, you can just observe second and third row. So you can do the swapping, that is R2 interchange with R3. If you do this, what you are getting, just observe it carefully. 1 2 3 7 is 0 1 7 9 0 9 10, and what you have, I guess, 22. Okay, so now see, in the next step you need to make this position 0. So for that, R3 dash tends to R3 minus 9 R1. If you are doing this 1 2 3 7 as it is 0 1 7 9, here you have 0 0, just see 0 9 10 22 if I am not wrong. So here 0, second row multiplied with 9 63, here 81. So here subtract, so 0 0, here 53, here what you have, see 81 minus 22. So 81 minus 22, if you are getting this, so just do the calculation. I think it is correct, yes. So here you are getting 53 and 59, is it correct? The calculation, you should check it. The previous calculation, I guess it is correct. Is it okay? So anyway, see, verify the calculation part, verify the calculation. Okay, starting from this step onwards, you just check the calculation. But the thing is, here you can see this part, it is from A matrix, and as a whole this is from A augmented B. So from this part only you can decide rank of A is what? Rank of A is 3. Okay, and from the entire matrix you can decide rank of A augmented B is what? 3. Okay, rank of A augmented B is what? 3. So thus you can conclude that rank of A is same as rank of A augmented B, that is 3. 3 is nothing but number of variable. That means the system has unique solution. Okay, unique solution, that means the system is consistent. Now see here, just observe these three equation carefully. These three equation, they will intersect at a particular point. Okay, these three equation means these three plane will intersect at a particular point. Okay, now this is how we can find by applying the row reduced echelon form. Okay, ultimately we have this one, and from here we can give the conclusion. Okay, so anyway, you should verify the calculation. Here I am not investing too much time on this calculation part, but you should do it. Now this is the second part where we observe the unique solution case. Previously we had the case where we had no solution. Okay, no solution, or in fact it was infinitely many solution. That was also the case for inconsistent situation. Now inconsistent, now we'll take another situation where we have infinitely many solutions. Suppose under the third one we are writing x plus y plus z is equals to 6, 2x plus 2y plus 2z is equals to 12, and x minus y is equals to 0. So you can try this one and you will find that rank of, try this, rank of A, it is same as rank of A augmented B, but it is not equal with 3. 3 is number of variable. So you will find that there is infinitely many solution. Okay, verify this one, infinitely many solution. Now see, when we have infinitely many solution case, that means it is also under the consistent situation. Okay, consistent. So we can claim that system is still consistent, but your solution, number of solution will be infinite. Now see, the analogy you can understand from here. See, in 2D you can have, suppose, two equation like this. This is the intersecting point, this point, it is the intersecting point. So it is the case for unique solution. Unique solution. Okay, fine. Now suppose these are the two lines you are having. Okay, they will never intersect. So in this case, this is the case for no solution. Or suppose this is one line and suppose this is another line. Okay, so here see, you have actually solution because they are intersecting through infinitely many points. Okay, so it is the case for infinitely many solution. So in the case of 3D also, you have either one particular point or one particular straight line, okay, or there is no solution. Okay, so these are the cases for consistency, inconsistency for a system of linear equation. Now see, when you have the understanding of this consistency case, you can have different type of question where they will ask you the question to find or to give the conclusion regarding this. Okay, now for that, this elementary row reduced form, okay, or the row reduced echelon form, this understanding should be clear to you. Okay, and through these two or three questions, we have tried to give you the idea how things work. Like see, this is the pivot entry. Okay, this pivot entry you need to make it 1, and below you have to make 0 0. Okay, next once you get this one, then this position you need to make it 1. So by just simply dividing that row you can do it, or simple process is this, if you have this type of option, then you can just do the interchange of rows and you will get this. Next, see, once you have this one as 1, so immediately you need to make this position as 0. Okay, so this is how we proceed, and ultimately this type of form will be getting. So in fact here, if you divide this 53 by 53, you will be getting as here 1. Okay, so like this we do it. Now that's it from this part. Now the next part is eigenvalue and eigenvector. So for that, we need to have few basic understanding of square matrix that we're just going to describe, and after that we'll start that eigenvalue and eigenvector.